Hi, my name is Lukas Kosiński and I am the CEO of Safe Studio, custom software and hardware development company. Welcome to the next episode of our course on creating medical devices software, more specifically using Qt framework. We are experts at this technology and 80% of our projects are for customers from the medical sector. So we thought that it was time to share some of our knowledge. In this episode, we will focus on choosing the right operating system for your needs, whether it should be a real-time operating system or a regular one, Windows or Linux, QNX or Zephyr. This episode will help you decide. Enjoy! Let's start with a simple clarification. During this episode, we will talk about choosing operating system not for all medical software projects, but only for embedded ones, meaning software projects that is integrated into closed physical devices. Otherwise it would be too simple. For projects that are about desktop or mobile, the key factor is which operating systems are used by the users. For embedded medical project, it is a bit more complicated. So, first of all, what are your options? I have seen a lot of medical projects built by giant corporates that were using desktop-grade operating systems like Windows or Ubuntu. And is it okay to do so? I would say that in some circumstances, yes, because a lot of medical devices are so expensive that putting a high-end microcomputer that can easily handle Windows does not make much difference. So if there is no need for a specific embedded operating system, then they choose a regular operating system. I don't necessarily like it, but it's how it is. It requires a bit of work with security and updates though. Another option is a specially designed system like Windows IoT, which comes in two options. Windows IoT Core, which is targeted for low-power resource-constrained devices, and Windows IoT Enterprise, targeted for more powerful devices with regular processors. This is a popular solution in many circles, and what I like in Windows IoT is that there's a possibility to completely disable automatic updates. Updates in embedded devices can cause a lot of issues. So it's important to have this possibility to disable them. Next option, different than desktop-grade operating system, is having a custom embedded Linux image. It means that you have to create your own Linux image using Buildroot or Yocto, and it allows you to choose only those packages, parts of the system's drivers that will be needed for your device to operate right. It brings several advantages like increased security, higher performance, smaller footprint, and also you have a better overview, better control over your system. On the other hand, it might be really difficult to find knowledgeable experts who know how to deal with it, so it might be cumbersome to maintain it over time. Nevertheless, custom Linux images are probably one of the best choices that you can make, allowing you to get the maximum out of your hardware. Yet another option is a real-time operating system. Real-time operating systems, RTOS, are widely used in the medical field for applications where timing and reliability are critical. Medical devices often need to process data, control hardware, respond to events in real time, all of that to ensure safe and effective treatment of the patient, right? So the essence of real-time system is that it guarantees that certain activities will be performed at a specific time. Traditional systems only use task, thread, process, priorities, but do not guarantee rigid time frames. The popular case for real-time systems are infusion pumps, as they have to dose precise amounts of medication at specific time frames. The latest option is no operating system. It is basically possible on the most low-level devices for the maximum performance. It means that software runs directly on the hardware, managing the hardware components and executing tasks with minimal overhead. That's often used by pulse oximeters, hearing aids, and many other small devices. The choice of software platform for an embedded medical device project depends on a wide range of factors. As like in every other case, you have to think about the requirements of the device and what it's supposed to do. Factors influencing this choice are following: complexity of the software, real-time requirements, power consumption, UX, UI needs, development time and cost, security and regulatory compliance, hardware compatibility. You also have to have this in mind. You have to think about maintenance and updates, and of course you have to think about cost of licensing of the operating system that you choose. I think that this episode would be too long if I had to talk about the details of how each issue is answered by a particular system, so feel free to stop now and look at this table to help you decide. If you don't know what option to go with, feel free to contact us at Saif so we can help you decide. There are plenty of options, and even in case of real-time operating systems, there are many solutions from various vendors. If you have a moment, I encourage you to visit our website and our blog. Links are in the description. Also, please hit the like button and subscribe to our channel. This way you help us spread our message to other knowledgeable people. Let's take a look at some of our demos to showcase how we approach choosing operating system, having in mind that it will be a huge simplification of the decision process. In the real world, everything should be backed up by a proper experimental R&D phase. So here I have our demo of DICOM viewer application. The medical staff often have to take a look at computer tomography or magnetic resonance scans to see what is happening with the patient. They use it in many cases, starting from dental to spinal or oncological surgeries. Such apps are used very often and extensive and should allow easy integration with other apps and systems to import or export data, even if it's on the same computer. So that's why for this demo we used Windows. Here we have a demo that mimics a medical device used for laser treatments. Such projects are usually closed physical devices with no need for spectacular UI effects, no need for real-time requirements, and so on. So here we've chosen to go with a custom Linux image, so our operating system have only the things that it has to have to operate in a way we want. It increases the security and it reduces long-term maintenance costs as there are less components to take care of. The next demo is the education virtual reality demo. Here we were forced to go with the operating system forced by VR goggles. There is basically no other option, right? We had to adjust. And here we have a project which is patient's vital parameters monitor. Customer wanted to reach the market as soon as possible, so to simplify the process, they decided to go with a ready out-of-the-shelf solution for the device, for the tablet, so they don't have to spend more time on engineering and applying all regulatory requirements. So here the choice of the system, operating system, was limited by the manufacturer of this medical tablet. As mentioned, the actual process is more complicated and there is no one go-to solution. The goal here was to show you the multitude of options. So how Qt supports particular operating systems? As mentioned in the previous episode, Qt is cross-platform, right? So most of the operating systems that are available on the market can run software developed using Qt framework. Of course, as Qt is so powerful framework, not all of the features are equally supported on all platforms. For example, microcontrollers don't have a GPU efficient enough to display a complex graphical effects on high resolution, right? Therefore, support is different platform to platform. You can read more about operating systems supported by Qt on their website. Remember that the choice of operating system has to be made together with the choice for embedded targets, so come back to the previous episode if you need some more instructions in this matter. For now, you have to know that with Qt, you can create medical apps for Windows, for desktop-grade Linux, for Windows IoT, custom Linux images, for QNX, which is probably the most popular real-time operating system for medical apps. You can develop also software for FreeRTOS, for VxWorks, for Integrity, and also for chosen microcontrollers with no system. Unfortunately, as for the day I record this course, there is no support for Zephyr. Zephyr is a popular RTOS system, but Qt joined the Zephyr project, so we can expect support for this system rather shortly. Thanks for watching this episode. And I know that choosing right operating system and appropriate hardware is a crucial step, so I hope that our course helps you. I hope that after watching this and the previous episode, it is a way clearer now. Hope you understand that I cannot just tell you go with QNX or go with Yocto, as each case is different, right? If you need help with either software or hardware evaluation or with Qt development, feel free to take a look at our website and contact us. You'll find all the links in the description. In the next episode, we will talk more about designing software architecture for medical devices. So see you there. We'll also talk about how Qt helps in this matter.